All right, so we have our decision variables and our objective function in. So let's go and now add the constraints to the problem in typical math style. Now, once again, we're going to be using that plus equals function to redefine that LP problem. So we're just starting to add other lines in there. So LP underscore prob plus equals, and our first constraint is that x1 has to be less than or equal to 600. Once again, we can put the spaces in there to make it more readable. And our next one is LP underscore problem plus equals. Let's do that. Another demand constraint, x2 is less than or equal to 1200. And this is something else that we can end up commenting if we wanted to. So we can sit here and go demand constraints, just so we remember what all this stuff is if we need to change it at some point. The next one will be the man hours or people hours or just work hours. We'll call it work hours. Work hours constraint. So we got LP underscore problem. I like using that tab so I don't misspell things. So the first one is 5 times x1. We actually have to put that times in there because I can't just put 5x1 because the computer doesn't understand that as math. And then 6 times x2. All of that together has to be less than or equal to 10,000, 3, and then LP underscore problem plus equals x1 plus 2 times x2 is less than or equal to 3,000. Just realized I have a comma in there. That should be a less than or equal to. Okay, so there are all of our constraints put in there. Well, the next thing is we want to display the problem so we know what's going on. So display the problem. The way we'll do that is we'll just go print. We'll say print our LP underscore problem. Okay, so let's just, let's spell print right first. Let's just run this and see what we've got. So we run it, and we have an unexpected keyword. I made a mistake somewhere, and it's in the low bound. Did I misspell it? Yeah, I did. There needs to be a capital B. It's always good to run this code as we're going through, just to find errors like that. Okay, so low bound. I've got that spelled right. That should work now. And there we go. So we've run the file, and our ideal computer mix, maximize. We are maximizing something 80 times the number of basic computers. So it took the name and dropped it in there. 129 times the number of XP computers plus 0. Number of basic computers is less than 600. Number of XP, less than 1200. The only thing is 5 number, there's no time sign there, but there we go. So we have all of that stuff put in there, just like range names with solver. And it tells us right now our variables are continuous. So these are not integer variables. We can have fractions, but we already know this problem is going to end up with whole numbers, so we don't have to do anything. Okay, so it's all set up. Let's solve it. So this part will be solver and printing solutions. So what do we need to do? Well, we're going to make a new variable called status, and this will be the variable that we shove our results into. And so we will go LP underscore prob. Now we're going to run a function on that, and so we do dot and solve. And so this will run the solve function on our linear program, and then we want to print, and then we're going to run from pulp our LP status, and what we want to grab is that variable that we just put in called status. So this will solve the equation, and this will give us all the statistics for that. So let's run that now and see what we got. Okay, so this all worked out fine here. And so now what we have is we've run through and wait, it just told us that we have optimal. So that means we have an optimal solution. That is our status, but we have no numbers. What happened? Remember, we got to tell the code to specifically do something. So it solved all this, but since we didn't tell it, hey, print those out, it's not going to do it. So let's write a couple lines of code to do that. So we're going to write some print statements. And so what we're going to do is we are going to print the final solution. And so we will go in here and go print. We should make, and then I want to append in the values of x1 and x2. And so they are numbers. I want to bring them as strings. So we're going to plus str to turn it into a string because it is a number right now. So p.value, and we want to do that of x1 because that's our one variable. And we'll, on the other end of that, put in a space and go basic computers. We're going to do the same thing with the XP. So let's just Control C and Control V this in to make ourselves a little bit lazy. And we'll just change that to X2. And we will change that to XP computers. And then let's say how much we actually want the objective, because we want to know how much money we make. So we'll sit here and print and say the final optimized profit is, I'll put a $sign in there so we know what's going on. We don't need a space because we want the $sign to run up to the number. So we're going to string in our objective value. So what we're going to do is we're going to use that same pulp value formula, except now we want to bring in LP underscore problem, so our problem, and then dot objective. And that will bring in our actual objective function. And so let's run that now and see what we get. Boom. We screwed something up. Where did I... So, line 45, we have our string. Oh, forgot parentheses. Because these are just like functions in Excel. This needs to be in parentheses, which is going to give us too much on this side. Okay, and I think we're good now. Let's run that again. Okay, there we go. So this is all the stuff from before. We should make 500 basic computers. We should make 1,200 XP computers. The final optimized profit is 199,600. Okay, so this is fine. We've gotten the solution. Let's make it a little bit prettier, because this is not typically how we'd write stuff. There are a couple different ways to do it. The easiest way is going to be to use a locale function, and that allows us to format time and money and stuff to certain locales. So what we're going to do is we're going to have up here, we always put the import stuff at the top, so we're going to import locale, and we're just going to leave it like that. We're not going to do anything. And so we're going to let it run everything to right before we print stuff. Let's go add a couple lines in to make things prettier. And so this is our currency formatting. And so what I want to do is let's make it a little bit easier on ourselves. Let's make a new variable called answer, or ANS. And so what we're going to do is we're going to grab that p.value, and we want to grab that of our objective. So LP underscore, what do we call that? Problem dot objective. Let's see, objective, did I spell it right? Yeah, it looks like I spelled it right. So it's basically the same thing that we strung in there. In fact, we're going to get rid of that. We're going to comment that one out because we're not going to need it, because we're going to do it with the locale function. So what we've done is we've pulled that answer out. We've jammed it into an answer variable to make things a little bit easier on ourselves. And so we're going to go locale, which is that function .set locale. And now we're going to do a category, And what we're just going to put in is we're going to run the function locale.lc, and actually it's the lc all, and then we're going to do a comma, and what we want to do is just a blank 1 tick mark. Okay, so we've set that little piece of code is going to set things for us for our American currency. And so then we're just going to go ANS equals, and so this is our answer, and we're just going to reformat it, basically go locale.currency, and then in there we are going to take our answer, and then we are going to also put on grouping true. Grouping equals true. This is going to help just format everything. So what's going on here? We are taking our objective, what we solved for, storing it as the answer. Then we're just running this piece of locale code so that we can reformat things. And so we're using the locale and the currency. We're taking answer, using the currency, and then restoring it as answer. Just like we've kind of done before, where you take a variable and you restore it on itself. And so now what we need is just one final line of code here to print the prettier answer. So print the final optimized profit is, and now I don't have to put the $sign in because I'm just going to string in my formatted answer. So we're going to string in ANS. We don't have to do anything else because this was all taken care of here. Now let's run that. And so there we go. You can see all the answers are just the same. We get here to the profit, and you can see that it it formatted it for American currency, put in the American $sign, put in the comma separator. That's where the grouping equals true comes into play, and so that's all set. So if we want to do this in euros, or if we want to do it in yen or zloty or Hong? I forget what the Chinese currency is. The ruble, any of these currencies, there is a little locale that we can set for it. How do we know which one? Well, we can just actually go on the internet, look up locale, and it'll give us all the little clicks that we need. But this is how we can use linear programming within Python to do a little problem that we've got here. I will do another one, probably in class, or another video showing a different Python maximization or minimization with some of the other problems that we've done. But with this is the end of a simple linear program using Python. If you have any questions, please let me know. Otherwise, I will see everyone in class.